So our next 3D shape we want to kind of talk about is a sphere. So remember, a sphere has no actual faces. It's not flat. So it's a lot different than your cubes and your rectangular solids or rectangular prisms. Its surface area is measuring the entire curved outside. So we want to try to find the surface area of like a basketball or a globe. To better understand how this happens, let me see if I can open up this little GeoGebra thing as well here. Let's see here. Let's see, I'll make this fit the screen. So again, a sphere is just a three-dimensional circle. So you almost kind of see rings. And notice how the rings kind of get fatter and smaller as well of all that. I can move this around a little bit. So one of the things we can do is to try to understand the surface is actually unfold this sphere. So if I start to unfold this sphere, notice how we have this top edge here is forming like a circumference, if you will. If we keep going, notice how, again, this is the distance around a circle, so that's the circumference. So we keep on going and keep going. Notice how this starts to break into a cylinder, but notice how there's no top or bottom to worry about. So this is really just one surface. So what I got to pick up on is, this surface here is the circumference around a circle. But also notice how we have this distance here. Where does where does this height come from? So if I start to put this back together again, notice how that height is from the top of the sphere to the bottom of the sphere. So notice how that's actually going through the middle of the sphere. So that's actually a diameter. Remember, a diameter is the same thing as two radii or two radiuses. Well, two radii is the proper way of saying that. So if I unfold this again, you'll see that this is becoming a circumference. And as I break it apart, we start to create this rectangle. So what we pick up on is this distance across here is actually the circumference, which is 2 pi r. But notice how this distance here is actually the diameter, or 2 radii. So if I multiply 2r times 2 pi r, if you will, so if I do that, area is going to be this 2 pi r times this 2r, because this one edge is the circumference, which is represented by 2 pi r, and this edge is actually 2 diameter. So if I put this all together, notice that I can move things around. So I can kind of move the twos times the twos, and then I can keep the pi where it is, and I can put the r's on the end, r times r. Well, we know that 2 times 2 is 4. Stands for 3.4. But notice that we can use an exponent here. R times r is the same thing as r to the power of 2. So we have a formula for the surface area. Surface area equals 4 times pi times the radius squared. So it's kind of cool to see that unfolding. That's the neat thing I like about some of the tools on the computer is you can better understand where some of these formulas are coming from. So I'll stop there on that. So let me get rid of this here. I keep forgetting to erase. So as we move into our assignment, you're starting to see then that, we're going to work with volume and surface area. But notice how the surface area of a sphere, they're going to use a capital S for surface area. Notice how they do get the formula 4 pi r squared. But notice how we kind of model that through this demonstration. So it's an unusual formula. But notice how, again, this is just going to be an approximation of the surface area because pi is usually rounded to 3.14. So we're getting a really close approximation of that surface area.